Aloha Algebra 2, we are chapter 5. Click that little chapter 5. We're notes. And today we are section 5-6. Okay, remember, that's always how you can go and get your notes, print them out, write on it digitally, whatever works for you. All right, let's get after this. Here's my little note packet. We are working on the fundamental theorem of algebra, the most important theorem in all of algebra. And really, we've been doing it already. We just take it one step further, right? That's how we always deal with math, all right? It always extends. So hopefully you've been successful with what we've been doing in 5.5, 5.4, and all the earlier sections, because we just take it one step further. So let's get after it, all right? Now, what we're going to do now is we're not just finding rational roots, we're finding all the roots. So what the heck does that mean? Well, that means we've got to find the rational roots first. And then after we do that, there might be some imaginary roots, okay? Because we're finding all of them. So the interesting thing here is that when it says to find all of the roots, and that's an x to the 5th as my first guy, guess how many roots I have to find? Cinco, go on. I got to find 5 of them. Okay, but the way we get it started, step 1, okay, and I'm going to have to erase here because these are big time problems. We're just doing 3 of them, so stay focused, stay with me, okay? The first thing we have to do when it says to find all roots are find the possible rational roots, right? That was 5. Okay, so we're going to find the possible rational roots. Now, how the heck do I find the possible rational roots? Well, that means I'm going to do the last guy, which is 4, and I have to find all the factors. What are the factors of 4? Well, it's a 1 plus or minus 1, 2 times 2, but remember, it could be a negative 2 times a negative 2, and a 4, because 1 times 4, or negative 1 times negative 4. And then the first guy is an ichi. There's a 1 out there on front, so that's going to be nice. The only way you can get that is a plus or minus 1. So remember, what we do now to find our possibilities is we do the little division. Okay, and I'm going to skip one step here. Let's divide those. 1 divided by 1 is 1, so that's a possibility. 2 divided by 1 is 2. 4 divided by 1 is 4. So there's really only 6 possibilities, okay? And we've got to find 5. Remember, 5 roots. And it's not just rational, it's rational and imaginary. What the heck does that mean? All right, well, let's go ahead and get started. And the way we get started is we use these, and we use our synthetic division to find out what works. Now, I already went through this because remember, when checking these possibilities, it could take a long time to find one that works. Now, I already did it, and guess what? 1 works. Okay, all right, so 1 works. So we're going to go ahead and step 2. We're going to do our synthetic division. Here's some notes for you, okay? We do synthetic division to find our rational roots. Okay, and it's a rational root if it's a factor, remember, and it's a factor if my remainder is 0. So that means we're going to put a 1 out here because I said 1 worked. Okay, and then remember, we're 1, -1, -3, 3, -4, and 4. Okay, so spling, 1 times 1 is 1. Ooh, combine 0, multiply 0, -3, multiply, -3. Ooh, another 0. What the heck is going on? Ooh, 0, -4, -4, 0. So that checks out. That means that is a factor. And remember, we always want to rewrite the problem we have, okay? So what's the problem we have? If 1 is a factor, and it is because I got 0 as a remainder, I rewrite this original problem as x minus 1. Remember, that's what it means to be a factor. And then we rewrite this guy up here. Remember, remainder, no x, x squared, x to the 3rd, x to the 4th. So what do I have left? I have x to the 4th minus 3x squared minus 4 is equal to 0. Okay? And then we just see if we can keep on going or if we're done. And guess what? This actually looks like some of those problems we factored. And it's a super duper fast one because there's a 1 right there. So wait, this one might not be too bad. So I'm going to go over here and do a little side work. I'm going to do my spling. And I do 1 times -4 is -4, and then the middle guy is a -3. Does anything work? And this is awesome. I can do it super duper fast again. But a 4 and a -1 gives me -4. But when I combine them, gives me a +3. So what do we do in that case? Flip flop. And that works. So guess what? I am done. And sometimes I have to keep on doing a synthetic division, right? But this was nice. Why? Because that is factorable. It's a trinomial. So remember, I can do this the super duper fast way. How do we do it the super duper fast way, Mr. T? Remember, if it's x to the fourth, that means it's an x squared and an x squared, okay? And then what do we have? We have a minus 4 and a plus 1, and it's still equal to 0. So now I really have 3 main factors right there, right? 1, 2, and 3. But Mr. T, you said I got to get 5 answers. Well, let's check this out. I could actually solve all of these, right? I'm going to do it in blue because these are my actual roots. X minus 1 equals 0, right? We already knew this guy because it worked there because it got 0 as a remainder. Factors will give you 0 as a remainder. All right, let's do this next guy. That's actually a difference of squares if you noticed it. But if I solve it, I can easily just solving it by adding the 4 and then square rooting both sides, which would give me plus or minus the square root of 4, and the square root of 4 is 2. Oh my gosh, I have 3 answers so far. Positive 1, a positive 2, and a negative 2. That's 3. I just need 2 more to go. Come on. Hopefully this last one gives it. Okay, and then we get x squared plus 1 equals 0. What the heck is this? That's x equals negative 1. X squared equals negative 1. Now I have to do a plus or minus square root of negative 1, but I can't have a negative in the square root, right? That's I. That's that imaginary, dude. So my answer here is going to be x equals plus or minus. Okay, it's I, and then I still have a square root of 1 class. What's the square root of 1? It's just 1. Sweet, I'm done. And guess what I got here? I got what I call 3 rational roots. So write that down in your notes. We have 3 rational roots. The rational roots are 1, 2, and negative 2. And I got 2 imaginary roots. What are the imaginary roots? A positive I and a negative I. But how many roots did I get in total, class? Go Bon. 5. So this is an example. It worked out really, really nicely. Do they always work out this nicely? No. So let's go ahead and we got 2 more to go. How about that? That's problem 1 done. If you understood it, you're doing a beautiful job. On the third one we do today. I want you to hit pause and see how far you can get on your own, all right? But this next one, let's make sure we do it again together, all right? I'm going to go ahead and get to my next page. I think it's erasing for me right now. Uh-oh. Let's pause this. Whew, that took a long time, you guys. I'm glad I can hit pause on this bad boy. All right, here is our next one. What are the roots again? Not just rational, but all the roots. Let's do it in blue this time. If you notice, this guy here has an equal sign right there. And the way we find roots is, well, I have to have a 0 on one side. So let's rewrite our problem here. X to the 4th plus 2x to the 3rd minus 13x squared plus 10x equals 0, right? I've got to get rid of those 2 guys. So I have to subtract that 13x squared and add that 10x. Now, if you notice here, we've got to do our little step 1, which is find all the rational roots, right? We have to find all the rational roots. So first we need our possibilities. And remember, our possibilities is the constant dude, the last dude. But I don't have a last dude on this one. Guess what? It is 0. That's the last dude. We are missing that constant guy, and the first guy is 1. So I'm just going to divide those 2 guys. Well, class, what's 0 divided by 1? It's 0. So that's the only guy. That's the only guy that could possibly work. So let's see if that bad boy works. How the heck does that work? Well, it's probably going to simplify some things for me. So we go like that, and then what the heck would this be? That'd be a 1, a 2, a negative 13, and a 10, and a 0 for that constant. So if I drop, I do 1 times 0 is 0. And then I do that, I get 2 times 0 is 0. Oh my gosh, look at how interesting this is. I get the same thing back, but I do get a remainder of 0, check, check. So, okay, I have a factor of 0, so I have to rewrite this, remember. How do I rewrite? Well, usually we write it as x minus something or x plus something. When it's just 0 is your factor, we just put an x out there. All right, and then remember, this is remainder, no x, x squared, and x to the 3rd. And that is a little bit different from the original problem. It's like each guy lost an x, and it's like factoring out an x is what we did right there. Okay, so now where do I go from here? Well, guess what? We have to start over. We've got to deal with this now. Now, the good thing about where I'm at now is I still have some roots I've got to check out. So I kind of restart that process. So let's do that, okay? And what I have to do now is I have to do it for this problem right here, which would be a plus or minus 10, or a 10, right? And how do you get a 10? Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And I'm still dividing by a 1 out front, so it's just a plus or minus 1 right there. And so let's go ahead and find out the possibilities for just this red part right here, right? That guy is already taken care of. So we're 1 divided by 1, plus or minus 1. 2 divided by 1, plus or minus 2. 5 divided by 1, plus or minus 5. 10 divided by 1, plus or minus 10. All right, and then I have to do synthetic division. That's really step 2, right? That was step 2 there. I got to do step 2 here. Synthetic division. All right, and then we're going to do one that picks. Remember, this can take a long time. And guess what? I did it earlier. Ichiban works. So 1 works again, which is awesome. Remember, if 1 didn't work, and how does it not work again? If you don't get a remainder of 0. Okay, so let's put the coefficients of that red, which would be a 1, a 2, a negative 13, and a 10. Okay, drop 1, 3, right? We just combine, multiply. Oh, sweet, 0, check. So what is left? Well, okay, you had that guy, so I got to continue that guy, and then I'm going to have to erase, right, class? X, and then we said that 1 worked, so then x minus 1 is a factor. See what I'm kind of doing here? And then what was left? That's the remainder. That's no x, that's x, and that's x squared. So we have x squared plus 3x minus 10, and it still equals 0. Now, I'm going to have to get myself more room. So since I'm going to have to get myself more room, I'm going to hit a quick pause, and I want to see if you guys can finish that guy right there. Okay, guys? Do it! Okay, so I really hope you guys tried it at home, because that's how you're going to get good at this stuff. So remember, I just need to do this right here. So that's going to be a little bit of side work here. 1 times negative. Oh, sweet. I can do this to super duper fast, right? Because there's a 1 right there and a 3 there. What works? A 5 and a negative 2, right? They multiply to get negative 10, and they combine to get a positive 3. And I can do it the super duper fast way, right? So I have your x. I have an x minus 1, and this guy factors down to 2 guys. That's an x squared, so it's an x and an x, because an x and an x makes an x squared. And then you have a plus 5 and a minus 2 equals 0. And then what do? Well, you've got spling, 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 right? Those are your answers. First guy is just x equals 0. Well, we knew that from earlier. This guy was x minus 1 equals 0, but we knew that, right? Because we did the synthetic division. And remember, the synthetic division gave us a remainder of 0, so it meant that was a factor. These guys, though, we didn't do synthetic division. We just factored, and we do x plus 5 equals 0, x equals negative 5. Whoa, that's a funky looking 5. And then we got x minus 2 equals 0, add 2, x equals 2. So how many answers did I get? 1, 2, 3, and 4. How did I know I got 4? Because it's the highest degree of 4. And guess what? They are all rational roots in this problem, right? There's nothing imaginary, which is super, super cool. And we'll talk about what that means graphically when we get to our next class. All right, we got one more to go. Hopefully this erases quickly. I'm still going to hit pause here so that I don't waste of your time. All right, here we go. Last one of the day. Hopefully it's a monster. Right? When these are monsters, they're just so much more fun. All right, what's another way the SAT could ask this question? It could be, what are the zeros, right? Remember, zeros means the same thing as roots, okay, of this particular function right there. Well, how would we attack this guy? You guys know we kind of have our steps. Step 1, what was step 1? Well, we want to know when it's equal to 0, okay? And the way we find out if it's equal to 0 is we find our rational roots. How do we find our rational roots? We first find the possibilities. How do we find the possibilities? It's the last dude, which is 18. Oh, snap. There's a lot of ways to get 18. Plus or minus 1 times plus or minus 18, right? Plus or minus 2 times plus or minus 9. Plus or minus 3 times plus or minus 6. Oh, my gosh, is that a lot? Luckily, the first dude's an ichi. So we got a 1, which is a plus or minus 1. So now we have to divide, right? 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 6 divided by 1 is 6. Whoa, what the what? 9 divided by 1 is 9, and 18 divided by 1 is 18. So, oh my gosh, 1, 2, 3, 4, 5, 6. Oh my gosh, there are 12 possibilities. That could be crazy talk. in terms of synthetic division, because I have to go to step 2 now, right, class, which is synthetic division. And I've got to find something that is a factor or a rational root, which means that when I do synthetic division, I will get a remainder of 0. Now, 1 doesn't work this time. -1 doesn't work this time. So you have to go all the way to tree, because I did it earlier. Okay, I didn't want to waste any of our time. So I got to go all the way to 3 to get a remainder of 0. And some of the times it's the luck of the draw. I'm going to give you a couple ways that you can maybe figure out which one works. Okay, and we'll talk about that in class. Make sure I remind me to give you that info in class. All right, let's see. Drop that 1. 1 times 3 is 3. Combine is 4. 4 times 3 is 12. Combine, I got a 5. 5 times 3 is 15. That gives me a 6. 6 times 3 is 18. Oh, sweet, 0, check. But I knew it. Okay, you guys at home. Oh, snap. I forgot to say to hit pause. Hit pause right now. Finish this bad boy out for me, okay? But this one, hopefully you hit pause and tried it, and then you ran into a little bit of trouble, because this one's a little bit different. Okay, so let's rewrite this. That is a factor. So far I'm at x minus 3, right? That's a factor. And then how do I write this guy? That's the remainder, no x, x squared, x to the third. What it does is it reduces the degree each time we do synthetic division, if you haven't noticed. Okay, and it still equals 0. Oh, snap. This means I got to do it again. Okay, I've got to do it again. But this limits my possibilities, if you notice. The last guy is a 6. The first guy is a 1. So let's go ahead and go blue here. The last guy is a 6, so that'd be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, right? The first guy is a 1. So believe it or not, it's just 1 divided by 1, right? We could do this whole thing again. Believe it or not, you could just use these guys again, though, okay? Because those guys would work out. But this kind of narrows down our possibilities. All right, so we have to do this again, class, because we can't factor this yet, right? We have to have that nice little 3, the trinomial, to factor. All right, once again, I did it earlier. Guess what? If 1 didn't work, if -1 didn't work, if -2 didn't work, and if 2 didn't work the first time, it's not going to work now. So the cool thing is you may have gone all the way to 3 and saw that it works. Well, let's try -3. Okay, let's see if -3 works. Okay, and then remember, when I fill out these guys in the next step, you do not use the original problem. Okay, you use this part that left you out. Okay, because you took out that factor. So we're 1, we're 4, we're 5, and we're 6. So it's less work. Okay, let's drop that. 1 times -3. Combine, multiply. -3. Boom, boom. Spling. Sweet. Factor. Rational root. All right, how do we rewrite this? So we're at x minus 3 for this first one. Remember that guy? This would be x plus 3. And then what the heck do I do with what's left? Well, remember, that would be, gosh, my face gets in the way. So it'd be x squared plus x plus 2, and that's equals 0, right? And it's equal to 0. Now, what I need you to do is to see if you can finish. Hit pause again, because I'm going to have to erase my screen. Get guys? Okay, you guys, I hope you tried that on your own. We're almost done, all right? Now we have to factor this bad boy, because it looks factorable. So I'm going to come over here, a little side work. You got a 2, you got a 1. Hopefully you tried this on your own, and guess what? Nada. Nothing works. Well, nothing works. What the heck do I do? Well, this gives you an answer. This gives you an answer, but you do have to find answers for that. Let's go ahead and do these guys, because it's nice and easy. Drop on easy. That's a rational root, right? We already knew that because it was a factor. It gave us a remainder of 0 when we did synthetic division. This guy here, x equals -3. We already knew that, right? That was a rational root. Then synthetic division, that gave me a remainder of 0. This guy here, I can't factor. If I can't factor, it is not a rational root. Well, if it's not a rational root, then that means it must be imaginary. So if it works out that I cannot factor it, that means that I have to do the quadratic formula. Sweet. All right. So to do the quadratic formula, remember, you need to know what A is. You need to know what B is. You need to know what C is. And remember, what is the quadratic formula? Do we remember? X equals the opposite of B plus or minus. What the what? What happens if I do that? Oh, man. Okay. But I think I just need to erase a little bit. Swing. Plus or minus the square root of b squared minus 4ac. Remember, that is the discriminant all over 2a. And remember, whenever we do these, we always do the discriminant first. So let's do it. We'll do it over here. B squared would be 1 squared minus 4 times a times c. If I do that, 1 squared is 1. Okay, and then I have to do multiplication. Negative 4 times 1 is negative 4. Negative 4 times 2 is negative 8. Negative 7. Remember, that would mean no solution, or in this case, it would mean imaginary. So now let's find my answers. And the best thing is if we get something like this that is not factorable and we do the quadratic formula, it just gets the answers for us. Okay, and you're going to find out right here. Here we go, x equals, right? Because these are all x equals, x equals. So this already gets us in that format. Opposite of b, what's the opposite of b? Well, the opposite of a positive one is a negative one. Plus or minus the square root of the discriminant, which would be negative 7, all over 2 times a. Okay, now remember, can we have a negative and a square root? No way, Jose. So we're at negative 1 plus or minus I square root 7. Do you guys know what the square root of 7 is? No, I don't know either. And I can't break it down, so I get to leave it like that. Boom. So guess what? You have 1, 2, 3, and 4. Remember, you could write your answer 2 ways there. How could I write my answer 2 ways? Well, my first answer would be x equals negative 1 plus I square root 7 over 2. And my other one would be negative 1 minus I square root 7 all over 2. So 1, 2, 3, and 4. The blue ones up here, those are rational. These guys are imaginary. But how many answers did I get? 5! All right, and that is it. I am going to go to my last page here. If you're really smart, you're going to hit pause here and try like 1 or 2 of these guys. We will go over more of these in class. It's a very difficult topic. The great news is if you're kind of understanding it and you can kind of flow with it, you are doing an amazing, amazing job at home. Make sure you guys continue to come in the AM. If you guys need any extra help, use the website to your advantage. If you're struggling with any past material, make sure you look at it. Aloha. I'll see you in class.